What is semantic web? Working, importance and applications. There is a tremendous amount of information on the internet that is exchanged in the form of websites and papers. Many web pages have hyperlinks that go to other pages. Previously, computers were capable of processing and displaying this data, but they were unable to comprehend any of it. That is when the notion of the semantic web was born. The semantic web is an attempt to explain and link web material in a machine-readable format. It is a web extension with the primary purpose of transforming the web from a web of documents to a web of data. This will be a comprehensive article on the semantic web and how it is used in the world of modern technology. What is semantic web? The semantic web is a knowledge network made up of linked data and intelligent content that allows machines to interpret and process content, metadata, and other information items at scale. It's a method for computers to swiftly comprehend and respond to complex human requests based on their meaning. This level of comprehension necessitates the semantic structuring of relevant knowledge sources, which is a demanding process. Giving the content the power to comprehend and deliver itself in the most helpful ways matched to a client's demand leads to smarter, more easy customer experiences. Semantic standards enable the web to evolve towards intelligence by allowing the stuff humans upload online to be presented in a way that machines can understand, link, and remix. The World Wide Web Consortium is in charge of the semantic web, W3C. It is commonly created using syntaxes that employ uniform resource identifiers, URIs, to describe data, and it is based on the W3Ca's Resource Description Framework, RDF. RDF syntaxes are the name for these types of syntaxes. The addition of data to RDF files allows computer programs or web spiders to search, discover, gather, evaluate, and analyze material on the internet. How is semantic web different from other webs? The term semantic denotes meaning or comprehension. As a result, the primary distinction between semantic web technologies and other data-related technologies, such as relational databases or the World Wide Web itself, is that the semantic web is concerned with data meaning rather than structure. Natural language processing, NLP, and semantic search are two more semantic technologies. In different courses, we will examine and contrast these technologies. This basic distinction results in a fundamentally different perspective on how to approach storing, accessing, and displaying data. This functionality is quite useful in some applications, such as those that refer to a significant quantity of data from several sources. Others do not, such as storing large amounts of highly organized transactional data. One of the main goals of the Semantic University is to figure out when it's a good idea to use semantic web technologies and when it's not. The engineering of semantic web. In the sense of artificial intelligence or machine learning, the semantic web does not make machines intelligent as some ML algorithms do. However, it complements and even overlaps with AI/ML. Explainable AI can be aided by the semantic web. Natural language processing, NLP, is an application field that uses semantically linked data to create chatbots and intelligent assistants. Content engineers are analyzing and organizing the individual parts of information that make up websites, such as people, events, ideas, concepts, and goods in order to create a more powerful and agile network of content and data. After that, these elements are given a label that describes their meaning in a standardized language. When such machine-readable descriptions exist, they may be linked to create a more robust network of data that allows computers to search, understand, and even reason about a unit of material. Semantic data is used in a variety of areas on the web, including specific search experiences. Because of this rich, new layer of data, search engines and other bots can deliver the most relevant content to users directly, cut down to the most crucial pieces, saving people time and effort. The basic building blocks of the semantic web are discussed herewith. The semantic web expands on the original web's roots. Metadata must be used to describe both old and new material. This information will help robots interpret data by identifying it, linking it to other data, and relating it to ideas. Metadata is information about information. Metadata adds information to data, making it easier to locate, utilize, and manage. Metadata comes in a multitude of forms, each with its own purpose, structure, quality, and volume. The following are some of the most common types of metadata: descriptive, structural, administrative, and statistical. Through references to ideas properly specified in a knowledge network, semantic metadata aids computers in interpreting the meaning of data. Knowledge graphs frequently include semantic metadata. This information will help computers interpret data by identifying it, linking it to other data, and relating it to ideas. Uniform Resource Identifier (URI) or Internationalized Resource Identifier (IRI) are used to uniquely identify data. The data model is provided by the Resource Description Framework (RDF). Ontologies or higher-level ontologies are used to add meaning. To put it another way, RDF defines syntax, whereas ontologies define meanings. RDF is the semantic web's building block, much as HTML was the original web's building component. The other two technical standards that are present in the semantic web are SPARQL and OWL. The semantic web's query language is SPARQL Protocol and RDF query language. It was created with the intent of querying data from several platforms. The semantic web's schema language or knowledge representation (KR) language is OWL or Web Ontology Language. OWL allows you to specify ideas in a modular manner so that they may be reused as much as feasible. Composability refers to the ability of each concept to be picked and constructed in numerous combinations with other concepts as needed for a variety of applications and purposes. The working of the semantic web. Here we discuss the working of the semantic web. Since Tim Berners-Concep's lease of the web, it has been developing toward semantics. Instead of people manually looking through a restricted list of links, algorithms now search through a massive number of more organized material sets to answer or act on a given query. The addition of semantics, structure and meaningful, machine-interpretable linkages to data allows computers to more precisely retrieve and modify information on our behalf. This leads to better content discovery and searches experiences, as well as more chances for seamless data sharing, recombination, analysis, and reuse, with less human contact in the loop. The use of those three technologies is one method to distinguish a semantic web application from any other application. The semantic web has been dubbed a variety of names, including Web 3.0 and the linked data web. Even in terms of the technical stack, some of these names have a lot of weight. The knowledge graph is a modern embodiment of semantic web technology. The semantic web goal has been hampered throughout time due to a variety of factors, including misdirected applications, a lack of scale, and perceived complexity. The knowledge graph concept has arisen to assist developers and decision-makers in constraining the development and deployment of semantic web standards more strictly. What is RDF in semantic web? Resource Description Framework, as the name implies, aids in the description of any resource that has a unique identity. To put it another way, RDF assists us in defining data about other data, i.e. metadata. RDF is made up of three parts: subject, predicate, and object. It's a remark regarding the subject's connection with the object. As a result, the location of Villa Nelcote in France may be described as an RDF triple. URIs, literals, and blank nodes are used to represent all three components of the triple. An RDF graph is created when many of these assertions are combined. The graph's nodes are subjects and objects. The connecting arcs are formed by predicates. RDF does not provide meaning to data on its own. RDF is a type of data paradigm that allows you to represent relationships. Vocabularies and ontologies are defined to provide meaning. These are usually expressed in terms of classes, their attributes, and their connections to other classes. For example, an RDF triple can convey that Paris is France's capital, but this makes little sense to a computer. Capital is a sort of city, city belongs to a nation, and country is a political entity according to a dictionary. This aids the computer in grasping the context, yet it will never fully comprehend what people do. Importance of semantic web. The semantic web's expansion and the tools it brings to the table are putting machines' analytical skills to work in the areas of content creation, management, learning, support, media, e-commerce, scientific research, knowledge management, and publishing in general. Knowledge will become meaningful anywhere we convey it. Although SEO and SERP ranking may be sufficient reasons, content discovery and display on Google and Bing is merely the tip of the iceberg. The developing semantic web of material and data is a big potential to tap into when it comes to intelligent content, semantic search, and smart devices. The semantic web will continue to give birth to new careers, businesses, and global innovators. Publishers can use semantic web technologies to create intelligent digital content infrastructures, connect disparate content silos throughout a large corporation, make use of information to create more immersive experiences, more effectively curate and utilize content, connect content sets from both inside and outside the company, invest in real-world augmented and artificial intelligence, enhance your authoring experiences and workflows. To engineer in a way that anticipates shifting content ecosystems, we must first comprehend the importance of semantic data linkages and gradually incorporate semantic information and relationships into every piece of material we create. Real-world applications of semantic web. Here are some applications of semantic web in real world. The oil and gas industry was reported to be using RDF-OWL in 2007 to combine data from various sources and standardize data exchange, sharing, and integration across partners or applications. It was also feasible to handle knowledge collaboratively. The BBC website employed semantic web technology to dynamically display material during the 2010 FIFA World Cup. We used Sparkle queries and OWL to RL reasoning. With the success of this project, in January 2013, BBC committed to the development of linked data platform to enable dynamic semantic publishing. BBC's music site from 2008 was also an early example of using the semantic web. Facebook announced Open Network in April 2010, allowing web publishers to incorporate their websites into Facebook's social graph. Facebook may then utilize this information to figure out what a user likes, provide customized suggestions, and connect individuals with similar interests. It was decided to use a reduced version of RDFA. Bottom line. As previously stated, the semantic web's primary purpose is to accelerate the growth of the current web by allowing users to search, find, share, and combine information with less effort. Though the semantic web's creation is a difficult and ever-changing process, one thing stays constant: it is slowly moving communication between people, software agents, and gadgets toward intelligent content infrastructures and a better collaborative future for humans. The semantic web ideas were quickly embraced in data and information management due to their ability to improve data creation, integration, and interpretation. Linked data is now used by a number of enterprises to publish master data internally.